I have been in the industry for almost 16 years now. So I started my career with Microsoft Corporation as a vendor employee and stayed with Microsoft Corporation for about 4 years. Then I joined as a regular developer of HP, Hewlett Packard, and stayed with the same team for about 8 years. And after that, I returned to Bangladesh, which is my own country, of course. And now I'm working with you. Okay. So this, as Shaunbhai said, is a first of a series of knowledge sharing sessions that we intend to do on microservices. It's not only knowledge sharing, we will be discussing pros and cons and whatever you want to discuss, because microservices are very important in modern software development. A lot of teams in worldwide, they are moving their system and their solutions to microservice. So this is our effort to understand microservice and how the software architecture actually evolved into microservice, because nothing comes from nothing. Everything comes from something. So let us start. So this is the code that was made by Albert Einstein. So what it means, how we can relate to it, is that everything is actually built on something. Every technology that we build, every construction that we make, actually we improve something, we refactor something, but that is actually based on our earlier experiences of this thing. So if you are a software developer, you know it very well. You write some code, then refactor it, make it better. You write some architecture, then you think that this is the best solution for the time, but then slowly you discover problems with it. You get more experience, and then you find better ways to do these things. So microservice is no exception. It also came to be because people had experiences with past architectures, and based on that experience, they came up with something new. So at the beginning, let us take a look at the agenda. We will be making a comparison of monolithic architecture, service-oriented architecture, and microservices. I'd like to say, or the way I'll put it, that these are the evolutionary steps of how the microservice came into being or became popular. We will be looking at the evolution, and we will be also talking a little bit about containers and virtual machines, because you very well know that microservices will not be possible, I'll not say impossible, will not be profitable without container. Then we will look at some design principles or properties of microservice, what defines a microservice, and how you can design it. But from theoretical perspective, it is totally platform agnostic. We will be looking at domain-driven design and the basic principles of microservice design. I mean, what you have to keep in mind when you are designing microservice. So let us move ahead. First, the evolution. This is something I'm not very familiar with this thing, the Zoom meeting. Anyway, the evolution. So here we are going to talk about some older architecture and what they offered. And people who worked on those architectures based on their experience, how this new architecture of microservice, the philosophy of microservice came into being. So let us take a look at first the monolithic application. So everyone knows what a monolith literally means. It means, if you don't know, if you know, that is good. If you don't know, it generally means a single rocky structure, a very big single rocky structure. So there are a lot of monoliths around the world. If you have interest, you can go to see some monoliths. So this picture here, it shows a monolith. This is not a natural monolith, actually. It's like something my colleague Munjir Ahmed picked up from his science fiction hobbies. Anyway, so it is showing a monolith, and there are little ape-men trying to get service from it, maybe. So this doesn't mean that I think that people who are using monolith or building monolith are less evolved. Don't think that. But as this structure of rock says, that signifies monolithic application is built as a single unit. You can deploy it on a cluster of servers, but it actually works as a single unit. Its responsibilities are not decoupled, generally not decoupled, are not distributed as a general sense, but there are more to it, of course, we know. So you all know what are the pros and cons of monolith. It obviously has advantages over other architectural design, but the problem is, first is, it is very difficult to maintain and very difficult to expand. As more logic gets added to it, it becomes problematic to manage it, and there are other concerns as well. We will be discussing all that after I have finished my presentation. There is a discussion session. We will be discussing all that. But I want you to understand that an application or a system is a monolith. That doesn't mean that it is bad. It might not be. It might not be the case. But anyway, let us move forward. So this is pretty much like a basic architecture, logical architecture of a monolithic application. You're all familiar with it. Has this presentation layer, then the application logic, then the business logic, data access, and the database, and how the client interacts with it. It's pretty simple. Everyone has, I believe, has worked with it and knows it, because in our life as software developers, we have all built monolith. Maybe I'm not sure about the very young software developers. I mean, I have been in the industry a long time, so modern software developers probably are different. I don't know if they build monolith in university or not. Maybe they do, maybe they don't, but that is how pretty much monolithic architecture works. I'm not going to explain the layers, because most of you already know what is contained within those layers, how we separate business logic from application and presentation, and how we separate the data layers, the data access object, and there are technologies in existence that existed for doing this job, but that's too technical. It's not within the context of this presentation. But as I say, there will be a series of presentations in next session, and the session after that, we'll be discussing a lot on what's moving forward. So now that people were building monoliths, so some people thought that why don't we create a distributed system where the whole software is divided into separate services. And every service does a specific job when it is called or needed, and they exchange data. And when everything comes together, the whole software will be functioning as single, but its responsibilities will be divided into smaller services. That will be easily manageable because maybe one team is working on one service only, another team is working on something else. So these two teams will actually not have to know that what is the business logic or technology used in the other service that is being developed by the other team, but they have to understand how these two services communicate. They have to understand the endpoints and the contracts. So if they can understand that, so the services will be communicating, and that will be easier to manage and develop and maintain. So this is like a basic idea of why people thought that why don't we divide the entire system into smaller services? Like think about it. Suppose you have a big system that actually does accounting and also keep tracks of customers and also keep tracks of very difficult business rules. Now, each of these things like managing customers or managing accounts or sending emails to customers, all these things might have complex business rules, right? You all understand what business rules are. It comes from the business domain. So all these things might have very complex business rules. Now, if we can separate them into smaller services, then all the business rules doesn't need to stay together and make it very, very difficult. For an example, the human resource management system, which is mainly the domain of human resource, they have a set of business rules, and there is the accounting system that is the domain of the account section. Now think about it that tomorrow the accounting section has some new business rules imposed on them by the top management. So if all the things are together, what will happen? So you have to develop code and they will get mixed. And that might create a problem. I'm not saying that it will create a problem, but there is a possibility that it might create a problem. So you keep these things in separate services. So when the accounting business rules are updated or they have new business rules, this will not affect the human resources. That's a simple idea. But as we all know, it's not as simple as that. I mean, when something is affected, everyone else is affected. That is the nature of things. So anyway, we take a look at we'll take a look at the structure of service-oriented architecture so that we can distinguish between service-oriented architecture and microservices. That is the main objective of presenting this. So now I will be discussing also this virtual machine. You all know that why the virtual machines are so important for service-oriented architecture. Now you see that someone decided that they will break down this big monolith into smaller services. But then the smaller services will have to be deployed on servers, right? It have to be deployed on machines, independent servers. But if we didn't have virtual machines, will that be easy? No. Because then you will be buying a lot of physical servers, and now those are expensive, right? So those are expensive, so you cannot, even if you have the logical structure and code developed for SOA, So if you didn't have virtual machines, it will certainly not be easy to deploy such a system into production. Now, you create great software, but if it is not profitable, then it will never see the light of production. That's how things are. So this is why the virtual machines are very important for service-oriented architecture. I myself have worked about 10 years on service-oriented architecture. And from my experience, I can tell you that without the virtual machines, it will be almost impossible to actually keep a service-oriented architecture in production. Almost. So, all right, now we take a look at what are the platforms and tools that you could use to build service-oriented architecture system. So generally, the service-oriented and different services of a service-oriented architecture communicated with each other based on SOAP protocol. Now, when I just graduated from university, we had distributed systems, and you remember the days when we had the Java RMI or .NET Remoting. Those were also protocols that you could use to invoke a remote object or a remote method. But then SOAP came to become very popular. So the service endpoints were developed using SOAP WCF web services or XML web services in the older version. I'm not going to explain or discuss SOAP here because that's too technical. But what we did, like we had those WSDLs, UDDI, like now for microservices, you can see the definition in the Swagger endpoint, right? The definition of the microservice. In WSDL, you could see the WCF-based endpoints definition, how you should communicate with the endpoint. You could see that from WSDL. The communication was mainly XML-based, and we used a lot of XSLT to map the data from one schema to another. Right? So some information data is coming in, you're using XSLT to convert it to your own canonical. This is somehow similar to how you use automappers in DTOs. You use DTOs to transfer data between the layers of your microservice. I'm not sure if the other platforms use DTOs or not, but .NET does. So all .NET developers know what I'm talking about. But XSLT is it's a little different, and I would say perhaps it's more powerful, probably. Yeah. Also, these services, those we built for service-oriented architecture, had the concept of canonical. Canonical is a concept is that, so you define a great big schema where most of your data is contained, and all the orchestrations inside your service use that canonical or creates their own canonical if they need to. And the outside ports from where the data from other services comes in, they will be mapped to your canonical through XSLT or some other method. I hope I'm not sounding too strange, because mapping of data is still relevant in today's microservices, but perhaps in a smaller scale. And we don't really use canonical in microservices. Bstock server, we use Bstock server. I worked it myself. I was a Bstock developer. So this is a tool that Microsoft, it's a solution. You can use it for integrating, because the Service-oriented architecture, we had this service bus which communicated with the service and other system and had business rules that would actually route the message. So Bstock Server offered great solution for that. It is a very nice integration tool and offers its own business rule engine that you can use for routing or decision making. So it is a good platform for creating integration between systems. It is still in use. I mean, just 2 weeks ago, I saw some Indian companies there hiring Bstock developers. So it is still in use and quite relevant. Windows Workflow Foundation is another tool, but I'd say it is a little lightweight compared to Bstock Server. The Workflow Foundation, when it was released in Windows Workflow was released in 3.0 was released with .NET 3.0 and then greatly upgraded in .NET 4.0. It also had benefits and it was lightweight and it also offered that you could create workflows with WWF. But still it didn't have the power of Bstock anyway. I'm not really sure if there are this kind of workflow development tools in other platforms or not. I think there are in Java platforms, because when I was working in Hewlett Packard, some of our services were actually developed in Java and some were even developed in C++. Not all services were developed with .NET. But I don't really know that what those teams used, if they used workflow to develop their services or not. So this is another example that when you break your big system into smaller services, actually the teams who are building these services, they don't have to use the same technology. Some teams might be developing their services in Java. Some other could use .NET to build their services, even C++ or other platforms. But what was common that most of the services used a SOAP-based endpoint, but some services actually had REST, REST endpoints. But that was less popular those days because everyone thought that less REST is less secure than SOAP, but SOAP is a lot more heavy. Anyway, so yeah, and also another thing about these services, those we build, these made heavy use of rule engines because these were created for bigger enterprise level software. It has global instances. So if you have ever used a business rule engine, you know it has its advantages, but it is also very process heavy. So you can understand that modern day microservices are actually a lot more sleeker, a lot more lightweight than the original services that we built in SOA. Let's take a look at general architecture of a SOA system. So you can see that this is the service bus. Service bus was the heart of a SOA-based system. Then there are services, different services. They communicate with the service bus, but these services were not totally independent in nature, as in they shared resources. Sometimes they will share database, sometimes some common library. So it is not totally independent, but they were independent based on their function, like every service performed a particular function. In that sense, they were independent. Then the enterprise service bus actually made sure that this service, the communication between the services and the data exchange and everything else is properly done. The ESB also had a lot of business rules defined for it. And these things sometimes will be deployed as a cluster of servers. Right, so that is how we built SOA. There are still a lot of SOA systems in the world. Not that everyone has moved to microservice. Probably in future they will. All right, so this is a basic BStock messaging and orchestration process. You can see these messages coming in the receive port. Then they get mapped, and then they are fed into the business process orchestration. There is the message database also, and after it has been processed, it is sent out to other endpoints through send ports, adapters, and pipeline. You don't have to understand all the nitty-gritty details of it. It's just a general system of processing message within a service that is integrated with the ESB. But why I'm showing this has some similarity. I mean, the concept came from here that a service will receive data, process it, and send out a reply. So this same principle or a part of it actually is applied into modern microservices. But modern microservices are a lot more slicker. We are going there. This is what a BStock orchestration looks like. It used a Xlang language that was built on the top of .NET and .NET Framework. So you could actually write some objects in C#, compile it into a .NET library, and use it with the Xlang in this orchestration. But orchestration also offered its own components. So you see that this looks like a workflow. So anyone in the software industry, if you have written documentation, you have designed workflow, you have written business flow that converts to code. So this actually looks like a workflow. Okay. It has all those decision sets and everything. Looks like a workflow. We can see something similar in Windows Workflow Foundation. They also let you create workflows. And actually now you're wondering that how these things are compiled and deployed. The compilation will result into a compiled DLL that you could deploy on servers. So now, after this SOA came into existence and people started using SOA systems and everything, but still it was very process heavy. It was very process heavy, and it was difficult to deploy because we didn't have a lot of automation in the past. So I remember that in Hewlett-Packard, we had to write deployment scripts, and those were nitty-gritty scripts that could deploy DLLs or import DLL into a server and add them to GSE. That is the global assembly cache. So it was a difficult process, and Hewlett-Packard actually hired a big team of infrastructure engineers so that they could manage it. Every time we built an application or updated an application, we had to hand it over to the infrastructure team, and they will deploy it to the already built virtual machines those were running. So it's not an easy process. It's troublesome. It creates conflicts sometimes because the deployment was bad. Then the system went down. I mean, they called me up at 2 o'clock in the morning. That's the past story. Anyway. So then the containers become popular. So in the understanding of microservice, container is very, very important, because without container, actually, it will be impossible to make a microservice productive. So it will be really impossible. So that's why we will be taking a look at the container and virtual machines. Both of these are virtualization of server, but what is the difference that and what are the advantages that container offers over virtual machine? So we will be taking a look at that, and it's probably not my personal opinion only that productive microservices will be impossible without container and container orchestration. So let us take a look at what a microservice is. By nature, a microservice is a collection of small autonomous services. So now you are wondering that, okay, service-oriented architecture also use services. Those were also smaller than a monolith. So why do we need microservices? Actually, the services in microservice are a lot more sleeker and smaller and lightweight than the services those we had in service-oriented architecture. And all these services in microservice are supposed to be independent. How they are independent, how do you make them independent, we will see very soon. So as it says that each service is self-contained. And actually, each of these services implements the smallest possible business capability. So, when I got hired in Cefalu, I had a discussion with my interviewers. We discussed a lot about microservice building, how a microservice can be built. I mean, they were probably wanting to know that how well I understand microservice, and they are right to do so. I would have done the same thing. So we discussed a lot about microservice. Even when I had my first meeting with my possible client, they also asked me one question, that what is my opinion, how I can separate a monolithic system into microservices. So there we had a very interesting conversation that how this can be done in a productive way, what is the principle anyway. So what we should focus on, bounded context. So what is a bounded context? We are going to see very soon. So the concept of bounded context is very important in microservice design. And we should focus on single business capability and possibly the smallest. Right, so it also talks about domain model. Now, what is the domain model? We will be taking a look at what is a domain-driven design and everything, so that it is also relevant to people who are not technical, because the domain models come from requirement. I mean, I'm a developer, so to my perspective, it comes from the business requirements. So domain model is, understanding domain model is also important for anyone working in the IT industry today, or working in collaboration with the developers today. So we move on. So here I'm trying to show the similarities and difference between virtual machines and containers. So you see that both of these are virtualization. It uses virtual technology, but what is the difference? Okay, so the difference is actually written here. The key difference between containers and virtual machine is the virtual machine virtualizes the entire machine down to the hardware layers. Containers do not. It only virtualizes the layer above, and actually the virtual machine VMs have their own kernel, so they use it for the IO operation. But the containers, they use the host operating system, the operating system that is hosting it. It's operating system's kernel. But there are a lot more things to it. The people who build containers or work with containers, who deep into it, they understand the differences and similarities. Also, the containers, they are created from images, right? The image has layers. So how we, anyway. That is probably will become too technical. But we will, if you want to have a separate knowledge sharing session on like how containers work, I think you can suggest the management to host one. Containers and container orchestration is very important these days, and how you host the containers in production. And the DevOps teams actually do only that. moving on. Yeah, I was just talking about container orchestration. So container orchestration is the automatic process for managing and scheduling the containers or a cluster of containers. Now, the microservices are hosted in containers. So we could say that this is also a system for managing and scheduling the microservices. So you have all heard about Kubernetes. It's a very powerful platform. But there are other container orchestration tools, like Azure has one. I know AWS has one of their own. Generally for development environment, I have mostly used Docker Compose, which is also a lightweight container orchestration, but probably now good for production level. But one thing to be noted that container technology has existed for a long, long time. It's not a new technology. It has existed for a long time. But why are you using it now? Why didn't we use it before? Actually, it became very, very popular after the container orchestration became popular. You could say that after Docker or Kubernetes. So what is the advantage of it? The advantage is that you actually do not have to hand build your software anymore and deploy it. I mean, add your DLLs to GSC or deploy it somewhere. It can be totally done with automation. And even you don't have to actually automate deploying your VMs anymore or provisioning your VMs anymore. And you just write a YML file and Kubernetes takes care of it. So the whole thing, I mean, you see, now you could, that gives the management a drastic advantage that they could cut down the size of the size of the team that is doing the deployment and maintenance, because most of it is automated now, or at least can be automated. So anyone who has worked with DevOps already know that it is a very popular tool among the developers now. In old days, we used VSS or TFS for managing our code, but we actually, the auto build system that we had in TFS was not so powerful as this one. Because now all we need to build is a container image. Then you push it into the registry. Then from there, it can be deployed to Kubernetes cluster. And this whole thing can be done using the pipelines, right? So this is a standard architecture of Kubernetes. I'm not going to discuss a lot about Kubernetes architecture because that will take a long time and it should be a separate discussion. But it's very important that it has those worker nodes and the scheduling and the management and everything that it provides to automate your deployment and management of your microservices in production. So how the worker nodes, pods, and everything works together. I think it is relevant to probably hold another session on that. Now we will take a deeper look into infrastructure and topology of microservices, because without understanding the topology, that how the microservices work together, it's actually meaningless, right? So the philosophy behind microservice architecture is that the services are independent and they have boundaries. We'll very soon take a look at the basic properties, but how they are independent and how they are maintained, how they are isolated from other services, and how they can communicate among each other. So this is a general architecture of a microservice-based system. So what I want you to pay attention to, that you can see there is this message broker, and each microservice has its own database. These databases are not shared. Every service actually owns its own database. This is the basic property of a microservice. The microservice sits behind the API gateway. And also there could be the aggregator microservice that actually does the heavy lifting that I'll say the direct HTTP call. We will take a look into it later. But how do the microservices communicate between themselves? Or suppose it's the publisher subscriber model that we can use through a message broker. Now, this architecture is pretty simple so that everyone can understand that how the microservices are built and deployed into production. So what happens, the web client or the mobile client makes a call to the microservice system. It comes to the API gateway, gets routed to the service, appropriate service, or if it needs to call multiple microservice, then we can use aggregator. We'll take a look at that later. And the microservices communicates in between them using message broker. This is very important for how I'll say, it is also important for data exchange. Sometimes need to replicate data that can be done through message broker, but for other instructions as well. Think about it. Suppose there is the customer is being processed using a microservice. So as soon as the customer has registered, an email will go out to the admin and also to the customer. Now, you certainly do not want to do that in the same service. What you will do, you'll probably create one microservice for managing the customer. After the customer registration is done, you will publish a message in the message broker that, okay, this is an event. It says that send out messages to administrator and also to the customer that your registration is successful, and you let the administrator know that a new customer has been registered in the system. And your messaging microservice, which is a separate microservice, it will subscribe to that message and send out these two emails to those people who is the administrator, who is the customer, to them, separate emails. So that's a very simple example of how the microservice to microservice communication can happen. But that's not it. There are a lot more to it. We'll discuss then probably when we dig deeper into microservice architecture in the next session. So the platform and tools to build microservices. Now, I have never built microservice on Java or Node.js. I have already built microservice on .NET Core platform and .NET 6. Also, I worked on a monolith on Django system. If you guys have used Python and Django, but I found that Django actually doesn't offer very good support for building microservices. But anyway, this is the general technology that you can use to build microservice. The endpoints are generally REST API or gRPC. The data is exchanged using JSON. There is the API gateway, and you have to use bounded context. The services will be containerized. You can use message broker. I have used Azure Service Bus mainly. Recently, I have used Rabbit, but a lot of people use Kafka, which in my opinion is a little different from RabbitMQ and Azure Service Bus, as those are like message streams. What they are, I do not want to discuss in detail, but these are the technologies available. For container orchestration, you can use Kubernetes or other container orchestration. Docker Compose is, in my opinion, is probably not a production level. People could argue, of course. Depends on what kind of container orchestration you need in production. Not everyone has the same needs. Moving on. So now we take a quick look at the CI and CD. And without this CI and CD, this continuous integration and continuous deployment, it will actually be very difficult to maintain a microservice system. Just the other day, I was having discussion with my colleague who was telling me they have a system built on 21 microservices. And trust me, some teams have more. So now you see, it's not really easy to deploy 21 microservices, okay? I have tried to make the manual deployment. You have to build all the microservices and push those microservices into registry. It takes a long time. Because in my last job, the production deployment part of it was manual because of data protection. It's really difficult and troublesome. And developers do not like to do this kind of work, right? They call it grunt work. But anyway, you don't have to do it anymore manually because there are these processes where you can use CI and CD. And it will be done automatically. Now, any of you, if you have worked with DevOps technology, you know that a CI/CD pipeline can be created with a simple YAML file. You write down the definition of the pipelines in the YAML, and you do a few configurations, and it's done. But this understanding of pipeline, it's very important for if you are building microservice, because I don't see that why someone will build microservices and not use CI/CD. Now here I'd like to mention that CI is not only used for microservices, it is probably used for other architecture as well. The CI offer you this ability that whenever the new code is pushed into repository, I hope you are all using separate feature branch to develop your code. That's the DevOps process anyway for developers. I hope you are doing that, because if you're not and everyone is pushing their code into develop branch, that will be disastrous for you to maintain. So what you see, the pipelines not only build, it can actually execute your auto test cases. Now that's a very important quality maintenance process, right? Right. So this is a general understanding of how build pipeline and release pipeline works and what they do, and what are the operations that they do. So I put this illustration here so that even non-technical people can understand what actually happened. Generally, what you will do, you'll create the pipeline and you will define these things in the YAML. Right? That is how it happens. These are some DevOps tools. I have never used AWS code pipeline, but I think people do. Jenkins, not a lot. I've used Azure DevOps and Kubernetes mainly. I also have familiarity with Jira and GitLab. There are other tools available and might be superior. We can discuss that in the discussion session. So we take a quick look at the properties of microservice. So if you are not working on microservice platform, and what defines a microservice? It's very basic 5 properties: single console, discrete, transportable, carries its own data, and inherently transient. So what do they mean? It means that every microservice should have a single concern. It should be smaller and should only do one single thing, not many things. That is the main thing. You can take a look at the description later so that you can understand it better. And it has to be discrete. That means it is discrete, it is separated from its environment and other microservices. How we do that? Well, there are a lot of process and techniques in place. With that, we can accomplish that, actually. And now, as you can see here, written here, that all microservices are deployed in containers. So that is also a unit of isolation created. Transportable. So yeah, so containers are easily, you can move containers very easily, right? Anyone who has built a container, who has built an image and container, they know that it can be moved very easily. It's relatively lightweight. Actually, it's very lightweight. You see in Docker, actually in my Docker compose, we use a lot of already pre-built images of services like my colleague Mondir Ahmed, who is a very brilliant software developer. He was asking me to show some implementation of Prometheus. So all I had to do is use the built image of Prometheus. I didn't actually need to build Prometheus, but it's very easily transportable. If you have created microservice, you already know that. For people, if you are new, this is the thing that you can there are repositories in the world, free repositories, and from where you can actually get built images already. But you have to be careful about how you publish your image in the image repository, because images have layers. That's a deep discussion. We'll do that later. Suffice to understand that microservices have to be easily transportable. Carries its own data. So that means we just saw that every microservice has its own database. But why does it have its own database? This concept of bounded context is very important for microservice. And when you are designing your domain model, we will see that very soon. It's very, very important to understand what your domain model should be and how they should be. Where do you draw the boundary of your domain model? This is very, very important. So yeah, microservices have their own data, and they have their own database, own domain model built around the bounded context. But it also says that what if some of a portion of the data is we need to share between the microservices. Now that is a very important question, and there are ways to do that, and a lot of people offer different techniques to do that. What are the pros and cons of it? Using these techniques, we can discuss in the discussion. Inherently transient. So a microservice have to be, not have to be, it's one of the properties of the microservice. It is easily created, easily destroyed, and it should be easy to deploy, and it should be easy to bring down. That is one of the properties of microservices. If something that you build does not have this property, it will be very difficult to call it a microservice. So since microservices are mainly deployed on containers, this is easy to do because we have all these container automation tools and everything. So if you have worked with Kubernetes, you know how you maintain the pods and how you can deploy the pods or take pod out of the nodes very easily. So let's not discuss the details here. To understand the property, that it have to be very easily creatable and destroyable. That is what it means to be transient. We take a look at a few design concepts. First is the domain-driven design. We will be discussing domain-driven design in a lot more details in our next series. So you see, like the main idea is that you have the business. Your requirement comes from the business, and the nouns in the business, they become your entities, right? That is the main concept of a whole domain. But how do you create the bounded context? We'll see it here. You have to identify the bounded context because that is what the microservice is based on. Also, like it is very important to understand entities, value objects, and especially aggregate and aggregate groups. If you are defining your domain, it's very important to understand them. But it's a little bit technical in nature, and I'm not going to discuss it now. In our next session, we'll discuss it. So this is what a general domain model would look like with bounded context. You see all these entities, they generally come from the business requirements. When you are given a SRS or a BRD, you'll see these things, how they interact, and what are the rules that define them, and what are the business rules of validating and everything. But it also, like I said, sometimes some of these, suppose this is a bounded context and this is one, some of the entities might have common properties or might be same, but there is a thing called the denormalization of entities that we use in domain design. I'm not sure if it is a good idea or not. We can discuss that later, but there might be overlap. That's what I'm trying to say. But it is better that you try to isolate your subdomains, that is the bounded context, as much as you can. Now, this is something I'd like to discuss here, the anemic domain model. The anemic domain model is like people build microservices, they build their domain models like without, sometimes they build these models, they only have properties and relationships, but no methods. Now, I'm not saying that bad because I think I have myself have designed microservices like that, domains like that, and it actually works. Then you keep all your business rules in the service layer and everything or in the separate classes. But that's probably not the best way to design your domain model because it creates a lot of problems later. And I have actually faced those problems. In our next session or the session after that, when we discuss the implementation and we discuss the deeper things in domains of domain model design, we can discuss that at that time. But there are a lot of microservices in the world that have been designed with dynamic domain model. So these are not actually principles, it's some guidelines. So first thing you do when you are designing your microservice, you identify your domain and then the bounded context. So this is, I think, the most important job, because the better designed your domain, your microservice will perform better in the later phase when it gets more and more data load and becomes more heavy with the business, and you add functionality to the system, everything. So, I mean, when it goes to the maintenance phase. Second is you have to try to keep your microservices small, but also cohesive. So like it says, like if you design two very small microservices and they are needing to communicate too much in between themselves, that is probably not a very good design. You should think about like combining those microservices. Maybe not. Well, there is nothing right and wrong here. I'm just saying that how you can make your system perform better. These are the things you have to take into account. The cohesion is very important. If your microservice is not cohesive, it's not going to be maintainable. Third is the layered approach. Now, this is the thing some people might disagree, because I have seen a lot of developers do not like layered approach in microservice. Well, they have their points, but I would still say that layered approach is we are all familiar with, and it's easy for developers to use a layer approach. So what kind of layers you can use in a microservice? Like there are different architectures, like a clean architecture or N layer, or there is also this modern CQRS, how you can use them and implement them. What are the layers? What do they mean? We'll discuss in the next session, but otherwise it will become too technical. I don't want to go there now. All right. So this is actually pretty much the end of my presentation. So before we begin our discussion, I'd like to mention something. You all know about concrete, right? Concrete is used in building materials. Yeah, everyone knows concrete because so you see, the Romans could build concrete 2,000 years ago. And their concrete was in some aspects better than what we have today. You see, the Roman structure, the structures they built, it actually withstood the time. Right? It is very erosion resistant. And they built the Colosseum, the whole dome is built with concrete, and it doesn't have the iron reinforcement that we have. But they lacked one thing. It doesn't have the tensile strength of modern concrete. So, but the modern concrete decays, right? Like they have used those modern concretes in Jamuna Bridge or Pamba Bridge. You'll see sometimes cracks show up in them very soon, right? Why does that happen? It's all about like how they mix the concrete, quality of the concrete. So what I'm trying to say is that you have built a new technology and you're using it. Maybe it is suitable for present time, but it doesn't necessarily mean that it is better than the old technology. So right, next enter the discussion. So here, if you have questions and you want to discuss them in Bengali, feel free to do that. I'll answer a question or we'll discuss things in Bengali if you are more comfortable with it. Yeah, so thank you.